All right, let's take a look at a problem that kind of at first appears to just be straight stoichiometry, but there's one major difference, okay? So take a look at this description here. It says if 20 grams of aluminum reacts with 150 grams of silver nitrate, what mass of solid silver is produced? Okay. Now this doesn't sound like something that's all that difficult. It sounds like something you've done a lot of. However, the difference is we get two different starting amounts. Okay, 20 grams of aluminum and 150 grams of silver nitrate. 20 grams here, 150 grams here. And that's not typical. Usually we were given one beginning amount and we were able to figure out what it would produce in the reaction. Now we've got two beginning amounts. Now, in reality, both of these numbers, if they're not exactly the right ratio, one of them is going to run out before the other one does. Okay, so it's important for us to figure out what that is. When we have two different reactants, one of them is called the limiting reactant, the one that runs out first, and one's called the excess reactant, the one that basically has some left over that doesn't get a chance to react. Once the limiting reactant is used up, the reaction stops. There's no more of the right combinations of things to put together. So what we really need to do before we start the actual stoichiometry is interpret these and see which one of these do we have extra of and which one runs out first. Now, it is kind of tough because it can be deceptive. You see 20 grams of aluminum and 150 grams of silver nitrate, you automatically look right here and go, wow, there's a lot of that. There must be quite a bit more. There's probably extra left over. But that's not necessarily the case. We can't interpret in terms of mass. We need to look at moles. And then we also need to look at the ratio that's necessary. So the first thing we're going to do is we're going to take 20 grams of aluminum and we're going to turn it to moles. Okay, 1 mole, 27 grams from the periodic table. And that gives me a value of about 0.74 moles. So I have about 0.74 moles, a little less than 1 mole of aluminum. Now let's do the same thing with silver nitrate. I got 150 grams of AgNO3. I'm going to turn it to moles, but this is a pretty heavy compound. Silver weighs 108 grams, nitrogen's 14, and oxygen is 16 times 3. So when you put all that together, you get 170 grams for the molar mass. So when I divide those right there, I'm going to get about 0.88 moles. So look at these amounts now. Let's not pay any attention to the grams. Just look at the moles that we're left with. Okay, right here. And this is where it requires not a whole lot of math, but just some thought. Okay, we're going to take a look up here, and then we're also going to pay attention to this ratio. According to this reaction, we're going to need 3 times the amount of silver nitrate that we have aluminum. We need this mole ratio tells us we need 3 moles of silver nitrate for every 1 mole of aluminum. Well, let's look at what we have. We have 0.88 moles of silver nitrate, 0.74 of aluminum. What we really need is we need our amount of silver nitrate to be 3 times the amount of aluminum if all of this were going to get used up. But this number is not 3 times as big. Not 3 times as big as this number over here. So the way we interpret that is, gosh, if we were going to use up all of this aluminum, we would need like 3 times this amount to make that happen. And we don't have 3 times that amount. So what it means is silver nitrate, even though there's a lot of it, that is going to be our limiting reactant. Okay, that's the one that is going to run out first. And once this is used up, there's going to be a whole bunch of this left over that never really got a chance to react. So see how it's kind of deceptive? You initially look at this amount and go, well, there's a lot of silver nitrate. But when you convert it to moles and you interpret the ratio that you need, this isn't near enough. This is not enough moles to use up all of that aluminum. So this one we would call our excess reactant, and this one is our limiting reactant. Now why that matters in stoichiometry is the excess reactant doesn't tell us much. The limiting reactant is the one that's going to get used up, and once it's used up, the reaction stops and you just have some leftover of other things. So what we need to do is we need to use the limiting reactant to do all of our stoichiometry. So I'm going to go do what I normally would do, but I'm going to reread this question and go, okay, now I'm going to be using silver nitrate as my starting stuff. I'm not going to pay attention to the aluminum because it doesn't all get used up. There's some left over. It's kind of a deceptive number. So right here, I got that my starting value. I'm trying to get mass of solid silver. So here's solid silver, and here's silver nitrate. Those are the two things I'm going to be analyzing. So I'm going to start with 150 grams silver nitrate. And you've already done this step, but I'm going to rewrite it just to make sure you can see how it fits with the bigger picture. I'm going to turn that to moles, silver nitrate. Then I'm going to turn it to moles of whatever I'm looking for. In this case, I'm looking for solid silver, so Ag. And then I'm going to turn it to grams, something that I can measure and compare and actually interpret fairly easy. So grams to moles to moles to grams. Now drag all your units down diagonally. So grams silver nitrate goes here, moles silver nitrate goes here, and moles of solid silver goes right there. Right here is my ratio. It comes from this and this. So it's a 3-to-3 ratio, and yes, you can cancel that out and simplify it, make it 1-to-1. Just wanted you to see where those numbers came from. And then the other two conversion factors are just the molar mass from the periodic table. We knew this one was 170, and silver by itself is 108. And when we put those together, we multiply everything on top and divide by everything on the bottom. All of these units are going to go away, and we're going to be left with grams of silver, which is what the question was asking for, and we get a value of 95.3 grams silver. Now this is not new to you. This is not new to you in terms of calculating moles, but the interpretation of which one is going to run out first. And it's not just the smaller number necessarily, it's based on the ratio of moles that I need. One's got to be twice as big or 3 times as big as something else. And we have to see what we have and what we need. In this case, this one ended up being the limiting reactant, so we use that as our starting value. If this was the limiting reactant aluminum, then we would use that as our starting value. Now, for those of you who like to do math but don't like to think, you have a way around this. We could just do 2 stoichiometry problems. Use this as a starting value, do all your stoichiometry, get an answer. Then we could use this as a starting value, redo all the stoichiometry, get a new answer. And the answer that is less is going to be the realistic one that actually shows what happens when the reaction stops and we got something left over. Okay? So you have those options. I prefer to think rather than just do math for the sake of math.